Hey guys, I'm going to tell you on the outset, this is going to be probably a pretty long set of notes, so be forewarned, take breaks as you need to, but I won't be able or be needing to see them until Thursday morning. So we're going to actually cover 2 lessons. I keep doing that. M8A, and we're going to be doing 1.5, and we're going to do 2.1, and we're basically talking about an introduction, so intro to equations. Now I'm going to give you a little heads up. This chapter is going to start off pretty easily, starting with how to solve different equations with variables and so on and so forth, doing translation. That's part of what we're going to talk about today. But then we're going to launch into word problems. Yeah, it's going to be real fun. So let's start with the 1.5. So when we have an equation, we have 3 possibilities for that equation. And we're talking pretty much at this point numerical equations, and that's what you're going to see. So you have 2 options, or 3 options, I'm sorry. I said 3 and then I changed my mind. It can be true, and by that, what's on the left is equal to what's on the right. It could be false, and what you get on the left is not equal to the right. And then we have this fun little guy called open. And open means it contains a variable. And because it contains a variable, that means we don't know if what's on the left is equal to the right unless somebody tells us what the variable equals, and then we can figure that out. Okay? So, how do we solve an open equation? Well, it's pretty simple. So, to determine if an open equation or open sentence, so I'm going to say sentence and then I'm going to put equation in parentheses, is true or false. So I'm going to give you some vocab here. You must test values from a replacement set. So we've used this idea of set, which is a group of numbers, and replacement is you're going to put that in for your variable and test it out. So it's actually kind of glorified substitution. So replacement set is a set of given values to substitute in for a variable. Now, the reality is, generally speaking, we pick from all real numbers. But sometimes, like you're going to see in your practice, that they're going to give you a specific group and you're going to have to test all of those numbers. Even though you get a solution, there could be more than one correct solution. There could be no solutions. They could all be solutions. You just don't know. It depends on the problem. So, any value that makes the equation true, so what's on the left is equal to what's on the right, is called a solution. And we've talked about that word before. Now, interestingly enough, as I briefly hit upon, equations can have one unique solution which would be something like x equals 8. It could have no solution, like 12 doesn't equal 7, okay? So what I want you to focus in on is the n, because we would say that there is never true. Also starts with that same letter. So if you have no solution, it's because you have something that's never true. And then there is actually a symbolic way of writing that, which would be a 0 with a slash through it. And the last possibility is infinite solutions. And that's where you might get something where a number is equal to itself, the variable is equal to itself. So this is, again, I'm going to circle up the I, because the solution is called an identity. Okay, so identity is you are who you are, a 4 is a 4, an X is an X, or you could have these answers as well would work. All real numbers. And if you remember from domain and range, you can use a symbol actually, we'll do the symbol version at the end. We'll have all real numbers. We can have, which means it's always true. And then our symbol for all real numbers is that cursive R. Okay? So the interesting thing is that equations can have more than one variable, so be prepared for that. Actually, at our level, you can have 2 different variables, so we figure out a way how to eliminate one of them in terms of the other guy, so then we can solve for one variable and then plug that answer back into the original equation and solve for the remaining variable. But when you get into higher math, you can have lots of unknowns. It'll be very interesting. So we're going to do some practice problems with this. And I'm going to give you an example. I'm just going to do a couple. We may do some together as a warm-up. So actually, I think we'll do this one example in class, and the rest I want to do together. So we're going to do some directions to say solve, and each one of them is going to have something slightly different happening in it. So we have the quantity 18 plus 4 plus m equals the quantity 5 minus 3 times m. So we would simplify using order of operations, and 18 plus 4 is 22. And over here, plus m, and then over here we get 8 take away 3 is 2, so we get 2m. So what we want to do is get variables on one side and constant on the other. So remember, a variable is a letter and a constant is a number only. The 2 is called a coefficient. I think we had this conversation before. And we get 22 equals 2m take away 1m is m. Now, this is where I use the symmetric property. Because I'm solving for m, I'm not solving for 22. So I do want to see that switched around. So I'm just going to remind you that this is the symmetric property of equality. Okay? So we've got m equals 22. So this is an example of one unique solution. Sorry, my cat is a little hyper right now. They get their burst of energy at night. Silly monster. Okay, next problem. We have 8 times 4 times k plus 9 times 5 is equal to quantity 36 minus 4 times k minus the quantity 2 times 5. Okay, let's see what we can do on this one. Actually, I'm not going to put that. So order of operations, we can take care of 8 times 4. We can actually do 8 times 4 times k, since k is a variable. 8 times 4 is 32, so we get 32k. We can actually do 9 times 5, since the product of one does not have any effect on the product of the other. That's going to be equal to 36, take away 4 is 32k, minus 2 times 5 is 10. Alright, so I'm going to go ahead and get my k's together. So I'm going to go ahead and subtract 32k from both sides. And what's weird is that they zero out. So what's left? 45 is equal to negative 10. Now, that is never true. 45 can never equal negative 10. So what do we say the answer is? We say it's no solution. Now remember the other option, or that symbol. So we can use either one of those to get the answer to this interesting problem. All right, and then the last one that I'm going to do with you, the rest we'll do in class. We've got 12 times the quantity, 10 minus 7, plus 9g is equal to g times the quantity, 2 squared, plus 5, and that plus 36. Okay, so we're going to start solving. We're going to do what's in the grouping symbol, so 10 take away 7 is 3. And then, again, in the grouping symbol, that's a g. Let's see, 2 squared is 4. So we get 4 plus 5 plus 36. So then we get 36 plus 9g equals g, and then times 9, which is 9g, plus 36. So if I try to get my g's together, I'm going to subtract 9g from both sides. And we end up with 36 equals 36. And guess what? That's always true. So because it's always true, we can say it's identity. We could say it's all real numbers. Oops, my pen was lagging. Or we can just use the cursive R. Okay? So that takes us to the second part, which is the 5.1, which is writing equations. So again, if you need to take a break, go for it. Just come back and finish up your notes. So we're going to go through a bunch of definitions, make sure we all are on the same page. Let's start with the word equation. And that is a mathematical sentence mathematical sentence that contains an equal sign oh, went too far. And usually a variable. We can have numerical equations. That would be boring, though. Like 3 plus 2 equals 4 plus 1. 5 equals 5. That's going to be true, okay? Let's talk about the word equal. So that is a to be verb. You're like, wait a second, what do you mean? Why are we doing English? But what I'm telling you is when you hear the word equal, that's why it's in quotations, it's something that's spoken or written. So that could be is, was, were, are, and so on. Or, again, is the same as. They're all telling you to write the equal sign. Okay. Now, we have a very special equation called a formula. So this goes with geometry. So it's a rule, it's not the only time, a rule, a lot of science has formulas, for the relationship between different quantities. So that's a fancy word for saying it could have lots of different variables. So we have formulas for converting Fahrenheit to Celsius and vice versa. We have formulas for areas and perimeters for certain shapes. We have formulas for surface area, volume. We have formulas that deal with distance versus speed and time. We have acceleration formulas. We have a ton of formulas, okay? And so we have to learn how to take a formula and use it. Then you need to get this word down, translate, because you're going to see this in your notes or your directions. So if you're asked to translate, it's telling you to do a couple things. So you're going to identify the unknown. So what's going on in the problem? What is the unknown? And that's going to be your variable. Okay, so we're going to use a variable to hold the place. So we're going to assign a variable. Assign a variable to the unknown. And define it. So basically you are going to give words from that sentence that you read in English that is going to be taken the place of by a variable. That was probably the worst thing I've ever said in my life. That was so crazy. So what words are you replacing the variable with? So for example, you would write something like x equals a number. So when we take the words a number, I don't know how to translate that any other way. I have no way to translate that, so that's when I'm going to start using a variable. Okay? And then you're going to write an equation that follows the order of the words. Now we've got a couple things to look out for. Look out for switcher phrases. Those are the ones that have than or from or to or divided into. Into is another one. Those are attached to other words, so less than, greater than, added to, divided into, that are going to switch the order of the numbers that you see. They're going to swap places, okay? So you got to watch out for them. And then you also need to make sure that the variable has an operation happening to it. Now, the reason why I mention this is that what happens is that some of you like to try to figure out how to solve the problem. So basically, I'll see two numbers with math happening, but there's no variable in sight. That's not an equation. There's no equal sign, right? And so then some people go, okay, I'll stick in a variable, x equals, and then 43 take away 21. That, I gotta be honest with you, I've seen several math books as a student and as a teacher. And I think in all of my years and years and years and years and years of schooling, either as a student or as an educator, once in the math book have I seen an equation that would translate literally with variable by itself equals, and then math happening to two numbers. So that's extraordinarily rare over decades of me looking in math books, okay? So when you translate, you're not trying to figure out what you're going to do to solve the problem. You're just writing what it says in the order that it says it. The only time the order will change is if it's a switcher phrase, okay? So the last thing I want to do is to remind you what I mean by this phrase. Define a variable. So it's got two little parts. One, you're going to choose a variable, so you get to choose. I'll be honest with you, my 8th grade algebra teacher, Mr. Cuneo, I got just X is it. I'm always X. So I try to break out of the X mold, but I just choose X. And then you're going to write what it represents. Write the words it replaces. Okay, because remember, we're taking the words right out of the problem. So here comes the fun bit. We're going to be writing down some word problems, and we're going to be kind of breaking them into equations. So unfortunately, if you decide not to write down these words, then you are completely getting nothing from our exercise. So your job is not to determine what's important. Your job is to copy everything I write. Okay, listen to everything I say. Translate each sentence, and if you haven't figured it out yet, yes, I do look at your notes. I look at your homework assignments. I look at everything. And if it's not done the way I've asked you to do it, then I'm going to tell you that, and you're going to lose some points. We already talked about that. All right, so translate each sentence into an equation. Some of you just need to tighten up things that you've done in the past. You need to pay attention to the details. 7 times a number squared is 5 times the difference of K and, oh, I've run myself out of room, so I'm just going to put it here, M. Okay. So, first thing I'm going to do is I'm going to look for some numbers. I see 7. I see 5. Squared is, I'm going to raise it to the second power. So that little caret means it's going to go up high. Okay, next I'm going to look for some operation words. We've got times, which I'm going to use a dot for that. Squared is kind of an operation word. Oh, here's another times. Oh, and then here's difference. So difference means to subtract. Okay. I'm looking for the word that means equals. There's your equals word, is. To be verb, right? So I see variable, k and m, so they're going to stay themselves. So let's just kind of circle them up. And the only thing I don't have is what to do with this guy. So this is going to become our unknown, okay? So that's going to be our unknown. So I'm going to go ahead and say x is going to take the place of the words a number. Okay? So now I'm going to translate. 7 times a number squared is 5 times, and it says the difference of. So the difference of is a grouping symbol, remember? So we're going to use parentheses. So we could do that. We can say that over here. The difference of is telling us to use parentheses. So I'm going to change my colors over here. That's not what I wanted. I wanted these guys. And because it's difference, and we take them exactly the order they were given. Okay? And we don't have to define K and M because they were given to us. Now that's all that they're going to ask us to do. That would be it. And that would be your answer. It's just to translate. Now, of course, we're going to get into a little deeper where you're going to have to translate it and then solve it. But this one you couldn't solve because there's too many unknowns and not enough information. So this one we've got 15 times a number subtracted from 80 is 25. Okay, so notice this one gave us some numbers, but not all of them. So let's go check them all out. 15, 80, 25. And then we look for words that mean operations. So we have times. Ooh. And then we have subtracted from. Okay? So first off, this is a switcher phrase. Now I'm going to add something here. What comes in front of subtracted from? What comes after it, directly after it, these are going to get switched around because this is a switcher phrase. So I'm going to put a little star next to this guy. Pink, 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 pink. Now we've got is our equals. And the only thing I haven't accounted for is a number. So that's going to be my variable. And I'm going to choose a y this time. All right, so then I'm going to go ahead and translate it. 15 times a number. which is y. Okay, but it says subtracted from 80. So we have to put the minus in front of it and the 80 in the very beginning. How weird is that, right? And then is 25. Now, we could solve this one because there's only one variable, but it didn't ask us to solve it. It asked us just to translate. Okay, so I'm going to do one more. And this one's going to make us write a little bit. So the area of a triangle equals the product of 1/2 the length of the base. Oops, that's more than I wanted to write. The length of the base and the height. So, in case you hadn't figured this out, this is what we call a formula. It's telling me that there is a relationship between area, the length of the base, and the height. So we actually have 3 unknowns in this problem. Okay, we have 3 unknowns. Area of the triangle, and I'm going to say area, but I'm going to put parentheses of triangle. We have the length of the base, so we're just going to call that B. A lot of you said, why don't we call it L? Because that stands for the length of the side of a rectangle. So B is the length of the base. And the height. Of the triangle. Okay? Those are the 3 unknowns that create this formula. So notice, here's your equals. So we're going to start off with the area of a triangle equals. And then it says the product of, which means I'm going to be multiplying. So times. And then 1/2 the length of the base and the height. So the product of 1/2 the length of the base and the height. So I do see this number of 1/2. So I'm going to have 1/2 the length of the base, which is the B, times the height. Now notice that anytime I have 2 variables or a number and a variable butted up to each other, that just means they're being multiplied. Okay? All right, I've got one more thing. We're going to go the other direction, and then we'll be done with this double set of notes. So the last one's going to make us go the other direction. So it's going to, let me start with the example. We're going to ask you to translate into a sentence. So they're going to give us the math, and we have to put in the words. So we're going to have and there's more than one way to do this. And so I'm just going to give you a way. So I'm just going to give it one big solid color. 6 times a number minus 15 is the same as, I'm giving you some variations, 45. So I did a long way of saying equals, or is, 45, okay? So that's another thing you would be doing on your homework. All right, good luck with this, guys, and we'll talk about it, I guess it'll be Thursday.